There's something moving through our solar system right now. Something that doesn't belong here. Something that came from somewhere else. And depending on who you ask, it's either the most exciting discovery of the year or the most misunderstood. Its name is 3I Atlas, the third confirmed interstellar object in human history, and for the past 4 months, it's been at the center of a scientific debate that goes far beyond a single piece of rock and ice. Some say it's just a comet, others say the data doesn't quite fit. A few whisper about possibilities we're not supposed to consider. But before we dive into the controversy, before we examine the evidence, before we take sides, let's start at the beginning. Let's talk about what we know for certain and what we don't. This is everything you need to know about 3I Atlas. July 1st, 2025. The Atlas Telescope in Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. It's a network of 4 telescopes designed to scan the sky every night, looking for objects that might pose a threat to Earth. Asteroids, comets, anything moving too close for comfort. On that night, it found something. A point of light. Dim. Moving. Nothing unusual about that. The system detects thousands of objects every month. Most are known asteroids. Cataloged, predictable. But this one was different. The trajectory was wrong. The speed was wrong. And within hours, astronomers realized they were looking at something they'd only seen twice before, an interstellar object, a visitor from beyond our solar system. They named it 3I Atlas. The 3I stands for Third Interstellar. The Atlas honors the telescope that found it. Simple, descriptive. But behind that simple name lies one of the most fascinating cosmic mysteries of our time. Let's talk about what makes something interstellar. It's all about velocity and trajectory. Every object in our solar system is bound by the sun's gravity. Planets, asteroids, comets, they all orbit. Their paths are elliptical, closed loops. They go around and come back. But 3I Atlas doesn't do that. According to StarWalk from October 2025, it's traveling at 210,000 kilometers per hour. That's about 58 kilometers per second. Its orbit isn't elliptical, it's hyperbolic, an open curve. It came from somewhere else. It's passing through, and it's never coming back. The mathematics doesn't lie. The gravitational calculations are precise. This object originated outside our solar system. That much is certain. But where did it come from? That's harder to answer. When you trace its trajectory backward, projecting where it's been for the past million years, you don't find a single star, you find empty space. Interstellar void. It's been wandering the galaxy, alone for longer than we can calculate. Think about that for a moment. This object has been traveling through the darkness between stars for millions, maybe billions of years. No sun warming it, no planets nearby, just the cold vacuum of space and the distant light of galaxies. Until by cosmic coincidence, it entered our neighborhood. When 3I Atlas was first spotted, astronomers immediately began analyzing it. What is it made of? How big is it? Where exactly is it going? These are standard questions. The answers came quickly, sort of. The first calculations suggested something massive. If all the brightness was just reflected sunlight, the object would have to be about 20 kilometers across. Huge, larger than most comets we've ever seen. That raised eyebrows. But then the Hubble Space Telescope took a closer look, and the picture changed. According to StarWalk from November 2025, Hubble's images showed that 3I Atlas isn't a single solid 20-kilometer rock. It's much smaller. The nucleus, the actual solid core, is estimated at somewhere between 0.6 and 5.6 kilometers in diameter. So where did all that brightness come from? From a cloud, a coma, dust and gas surrounding the nucleus. When the object got closer to the sun, the ice on its surface began to sublimate, turn directly from solid to gas. That gas carried dust particles with it, creating a glowing cloud around the core. From Earth, with our early telescopes, we saw the whole cloud and thought it was all solid. Classic case of misinterpretation. It happens. Science corrects itself, we learn, we adjust, no problem. So at this point, the picture seemed clear. 3I Atlas is a comet, an icy body from another star system. It's warming up as it approaches our sun. It's releasing gas and dust, completely normal behavior for a comet, just from somewhere else. NASA agreed. The European Space Agency agreed. Most astronomers agreed. The data fit. The explanation made sense. Mystery solved. Except, not everyone was convinced. Enter Professor Avi Loeb, Harvard University, director of the Institute for Theory and Computation, former chair of the astronomy department. over 200 scientific publications, a man respected and controversial in equal measure. Loeb looked at the same data, and he saw problems. First, the acceleration. According to Newsweek from October 31st, 2025, Loeb published calculations showing that 3I Atlas experienced what's called non-gravitational acceleration. That means it sped up in a way that gravity alone couldn't explain. Now, for a comet, that's normal. The outgassing, the jets of gas escaping from the surface, they push the comet slightly, like a very gentle rocket engine. We've seen this with many comets in our own solar system. It's expected, it's understood, but Loeb did the math. He calculated how much gas would need to escape to produce the observed acceleration, and according to his analysis, 3I Atlas would have had to lose at least 10% of its total mass. 10% in a very short time, that's a lot. That's a violent amount of outgassing. And if that much material was ejected, it should create a dense, thick cloud of gas around the object. Something we should be able to see easily with our current telescopes. Something obvious, something unmistakable. Loeb's prediction, according to Newsweek from November 4th, was clear. If the outgassing explanation is correct, we should see a massive gas cloud in November and December of 2025. The European Space Agency has the equipment, the observations are ongoing, we should see it. And if we don't, if the gas cloud isn't there, then where did the acceleration come from? Then there's the chemistry. According to Orbital Today from October 22nd, 2025, spectroscopic analysis of 3I Atlas revealed the presence of nickel tetracarbonyl. That's a compound, nickel bonded with carbon monoxide. On Earth, it's used in industrial processes, refining nickel, creating metal alloys. It's manufactured, synthesized.
In space, it's rare, not impossible, but unusual, very unusual.
Loeb pointed this out. He said, according to the same source, there is only one place where that is known to exist, in industrially produced nickel alloys. Now that doesn't mean 3I Atlas is artificial. Natural processes can create all kinds of unexpected chemistry. The universe is vast and strange. Just because we haven't seen something before doesn't mean it can't occur naturally. But it raises questions. It adds to the pile of things that don't quite fit the simple explanation. It makes you pause, makes you wonder. Let's be clear about something. This isn't Loeb's first time making controversial suggestions. In 2017, when Oumuamua, the first interstellar object, was discovered, Loeb suggested it might be artificial, a light sail, an alien probe, something sent by another civilization. The scientific community reacted strongly. Some praised him for thinking outside the box, for considering all possibilities. Others accused him of sensationalism, of jumping to conclusions without sufficient evidence, of seeking attention. Loeb wrote a book, Extraterrestrial. It became a bestseller, he became famous, he became polarizing, and 8 years later, here he is again, with a new interstellar object, and similar questions. According to Orbital Today, from October 22nd, critics say Loeb's approach risks blurring the line between legitimate scientific inquiry and speculation, that extraordinary claims require extraordinary evidence, that we should exhaust all natural explanations before even considering artificial origins. And they're right. That is the scientific method. You start with the simplest explanation, you test it rigorously. Only when it fails do you move to more complex theories. That's how science works. That's how it should work. But Loeb would argue, and has argued, that we shouldn't dismiss possibilities just because they make us uncomfortable. That if the simple explanation has holes, we should acknowledge those holes. That being overly cautious can also mean missing the truth. Who's right? That depends on the data, and the data is still coming in. So let's talk about the other side. Dr. Daryl Seligman, planetary scientist at Michigan State University, expert in interstellar objects. He told Newsweek in early November 2025, there is a significant amount of peer-reviewed literature. The analysis of these efforts from many astronomers around the globe show that to the best of our knowledge, 3I Atlas is consistent with having a natural origin. He continued, its properties to date are consistent with it being an icy planetesimal that formed around another star in the galaxy and was later gravitationally scattered out of its home planetary system. That's the mainstream scientific position, and it's backed by data. Lots of data, multiple independent observations, spectroscopic analysis, orbital mechanics, chemical composition studies, all of it pointing to the same conclusion, natural comet. Seligman also said, there is no evidence to date to point toward 3I Atlas being an alien spacecraft at this time. Notice the phrasing, at this time. Science doesn't deal in absolutes, it deals in probabilities, based on current evidence. always ready to revise if new data emerges. That's the strength of the scientific method. It's self-correcting. So we have two camps, both scientific, both looking at the same object, both using the same tools, but arriving at different conclusions about what the evidence means. NASA and the ESA and the majority of astronomers say it's a comet. The data fits. We understand what we're seeing. Loeb says there are anomalies, things that don't quite add up. We should keep all options open. Both are applying the scientific method, just with different levels of caution, different thresholds for what counts as sufficient explanation. Here's what makes this fascinating. We're living through the test, right now, in real time. According to Starwalk from November 2025, 3I Atlas reached its closest point to the Sun, called perihelion, on October 29th, 110 million kilometers away. That's about 3/4 the distance from Earth to the Sun. Close enough to warm significantly, close enough for major outgassing if the comet explanation is correct. At perihelion, 3I Atlas was too close to the Sun's glare to observe directly. It disappeared from view for several weeks, a solar conjunction, standard astronomy problem. You can't look at something when it's right next to the Sun from our perspective. But now, in November, it's emerged into the morning sky. The telescopes can see it again, and the observations are happening. Multiple facilities, multiple wavelengths. The data is being collected right now. If Loeb is correct, we should see a massive gas cloud. Dense, obvious, the result of that 10% mass loss. The European Space Agency has the capability. The technology exists, it's just a matter of looking. And if we don't see it, if the gas cloud is smaller than expected or absent entirely, then we have a problem. Then the outgassing explanation doesn't fully work. Then we need a different answer for the acceleration. That doesn't automatically mean alien technology. There could be a natural process we don't understand yet. Maybe comets from other star systems behave differently. Maybe the composition is unusual in ways we haven't anticipated. Maybe our models are incomplete. Or maybe Loeb is onto something. The beauty of this situation is that we'll know soon. This isn't a debate that will drag on for decades. The observations are happening now. The data will either show the gas cloud or it won't. Science will do what science does: test, measure, analyze, conclude. Let's zoom out for a moment. Let's talk about what 3I Atlas represents, regardless of what it turns out to be. This is only the third confirmed interstellar object in human history. The first, Oumuamua, came in 2017. Unexpected, strange shape, accelerated mysteriously, sparked debates that continue today. The second, 2I Borisov, came in 2019. Looked like a comet, acted like a comet, reassuring, normal. Now 3I Atlas, and the debates begin again. Think about what that means. For all of human history until 2017, we never saw an interstellar object. Not once. We theorized they should exist. We knew that stars eject comets and asteroids during planetary formation. Gravitational interactions throw material out into the galaxy. It drifts, it wanders. Some of it should pass through our solar system occasionally. But we never saw one, until we did. And now we've seen 3 in 8 years. That's not because they suddenly started appearing. It's because our telescopes got better. Our detection systems improved. We're finally able to see what's been passing through all along. Invisible visitors we never noticed. How many did we miss? How many interstellar objects flew past Earth in the 20th century before we had the technology to detect them? Dozens, hundreds, we'll never know. But now we can see them, and each one teaches us something about other solar systems, about planetary formation, about the galaxy we live in, about how common these wanderers are. According to some estimates, at any given time, there might be dozens of interstellar objects in our solar system. Small, dim, moving through. Most we'll never detect. They're too far away, too faint, moving too fast, but they're there.
The galaxy is more connected than we thought. Material from one star system reaches another, constantly. We're not isolated islands. We're part of a network, a vast, slow exchange of matter across light years.
And maybe, just maybe, some of that matter carries something more than rock and ice. Let's address the question directly. Could 3I Atlas be artificial? Could it be a probe, a vessel, something created by another civilization?
Honestly, probably not. The evidence for natural origin is strong. The comet explanation fits most of the data. The anomalies Loeb points to could have natural explanations we haven't thought of yet. Occam's razor suggests we go with the simpler answer.
But we don't know for certain. Not yet. And that's important to acknowledge. Science isn't about certainty. It's about evidence and probability. And the probability strongly favors a natural object. but strongly isn't the same as definitely. If it were artificial, what would we expect to see? Signals, maybe. Radio transmissions. Some indication of power or propulsion or control. We haven't detected any of that. SETI, the search for extraterrestrial intelligence, looked, they found nothing. According to all our instruments, 3I Atlas is silent, inert, not broadcasting, not maneuvering deliberately. But then again, an ancient probe, millions of years old, might not be functioning anymore, or it might be designed to be silent, or we might not know what to look for. Our technology is limited. Our understanding is limited. The universe is under no obligation to make sense to us. Here's what we know for certain. 3I Atlas is real. It's interstellar. It's passing through our solar system right now. It will reach its closest point to Earth in late November, still about 30 million kilometers away. Far, safe, no threat. And then it will continue on, out past Mars, past Jupiter, past Neptune, back into the darkness between stars. In a few years, it will leave our solar system completely. Its speed is too great. The sun's gravity can't hold it. It's just passing through. We'll never see it again. This is our only chance. These few months, these observations, this data, when it's gone forever. That makes every measurement precious, every photograph valuable, every spectrum analyzed a piece of a puzzle will only solve once. In the coming weeks, more papers will be published, more data will be released, the scientific community will analyze and debate and argue. That's healthy, that's how science works. Not through consensus, but through challenge and evidence and rigorous testing. Maybe we'll get a definitive answer, maybe we won't. Maybe 3I Atlas will remain a mystery even after it leaves. A visitor we observed but never fully understood. What does this mean for us? For you listening to this? For humanity? It means we're living in an extraordinary time. The age of interstellar archaeology has begun. We're no longer limited to studying our own solar system. We can examine material from other stars, other worlds, other histories. Every interstellar object is a time capsule. A sample from a planetary system we'll never visit. It carries information about how that system formed, what elements it contains, what processes shaped it. 3I Atlas formed around a star whose light might not even reach us yet, or maybe it died long ago. We don't know, but this object remembers. Its chemistry remembers, its structure remembers. It's a witness to a history light years away. And we get to study it. We get to learn from it. That's remarkable. That's a privilege our ancestors never had. Whether it's a comet or something else, whether Loeb is right or NASA is right, the fact that we're having this conversation at all is extraordinary. The fact that we can detect these objects, analyze them, debate their nature, that's progress. That's the culmination of centuries of scientific advancement. So where does that leave us? What's the truth about 3I Atlas? The honest answer is we don't know yet. Not completely. The data is incomplete. The observations are ongoing. In science, I don't know is a perfectly valid answer. It's not a failure, it's an invitation to learn more. What we do know is that 3I Atlas is a visitor from beyond, a traveler from the space between stars. It's been wandering the galaxy longer than our species has existed. And for a brief moment, a cosmic eye blink, our paths crossed. We saw it, we measured it, we wondered about it. And whether it's a frozen chunk of ice and rock or something stranger, that encounter matters. It expands our understanding, it challenges our assumptions, it reminds us that the universe is bigger and stranger than we can imagine. The telescopes are watching. The data is coming in. Soon, maybe very soon, we'll have our answer about the gas cloud, about the outgassing, about whether the simple explanation holds. And if it does, then 3I Atlas is a comet, an extraordinary comet, a messenger from another star, but a natural object nonetheless. And that's beautiful in its own right. And if it doesn't, if the anomalies persist, if Loeb's questions remain unanswered, then the mystery deepens. Then we keep looking, keep questioning, keep searching for the truth. Because that's what we do. We're the species that looks up, that wonders, that asks what if. 3I Atlas is moving away from us now. Every day, a little farther, a little dimmer. Soon it will be beyond the reach of even our best telescopes, a fading point of light, and then nothing, back to the darkness. But the questions it raised will remain, the debates will continue, and the next interstellar visitor, whenever it comes, will be met with better tools, better questions, better understanding, because we're learning, slowly, carefully, but we're learning. The universe is speaking, and we're finally learning how to listen. The truth is out there, and maybe, just maybe, we're getting closer to hearing it. What do you believe?